Okay, welcome to today's video. I actually got a couple of instrument clusters in the mail, but this one's going to be the one that I'm going to showcase in a video. So this one, the request was to add trans temp to it. This is a mail, and this is all what I got. I didn't get the whole cluster, so we're not putting the inlay or the motor or any of that in. We're just adding the chip, programming it, and putting the other missing components on to make trans temp work. Pretty simple one. I've already done one video on this before, but it doesn't have a ton of views, and I'd really like to, showcase this again, that you can, in fact, add trans temp to the 99 to 02 instrument clusters. A lot of people believe it can't be done. It's said, oh, that's impossible, you can't do it. It's not like the 03 to 07s, which it is not like the 03 to 07s. Because the 03 to 07, all that you have to do, stick a stepper motor on and program it, and you're done. There's a couple of more steps involved in this, but it's nothing too crazy, nothing impossible, and it's still relatively low cost to add it to here. The expensive part on adding trans temp to one is the inlay, and I haven't found very many good options of inlays for the 99 to 02 instrument clusters that have trans temp on them that are aftermarket, but it's an economical repair to do, at least, or modification to do to this circuit board. Really your main roadblock is then just the inlay that you need to find, and finding one that you like and you're happy with. And some of you may actually be happy with the cheaper ones. So there's two cheap ones that you can get. One of them's red, the other one's white, and they really just, the light doesn't come through them very well. And then your other option is to go with like US Speedo, and they're quite expensive inlays, which, yeah, in my opinion, if you go with the US Speedo inlay for doing this kind of modification, it's just not economical. It just doesn't make sense to do. But yeah, let's flip this thing over. Let's take this screen off. While we have the screen off, we'll go ahead and do the normal repair to it. I'm not exactly sure what happened, if it was in shipping or if it was just in the storage on a shelf, but screen got smushed down a little bit, but no obvious signs of damage to it. So yeah, let's get this going, and we'll continue on with the modification from there. Okay, so you might have noticed when I was desoldering this that I forgot there's conformal coating on there. It's been a couple of weeks since I dealt with one of these and just escaped my mind. So I got started and it was like, why is this not desoldering? So yeah, you always want to scrape that conformal coating off before you start soldering. A lot of times I'll see it where people struggle to repair the connectors if they have cracked solder joints on there, and it's normally a twofold problem that they had. They were using lead-free solder and having difficulty with that, and they just did not remove any of the not solder mask, but conformal coating, and then that conformal coating just becomes a contaminant and makes it just really hard to solder to. Now I'm just opening up all of these through holes for all the different parts that we have to solder on here. These ones are just little jumpers that go across. That's the motor driver IC. And that should be all of them. Let me flip it back over and double check. Yep, and yep. So that is all of those. So this is the motor driver IC here. It is a Phillips chip with a GM part number on it. I'm not 100% sure what Phillips chip it is. I've emailed them before and asked them, and they would not tell me. They said that it did not match anything in their database. Then I explained that it came out of a GM product, and they said, okay, it's a product that we made for GM. And I said, okay, GM normally just uses an off-the-shelf product and puts their part number on it. quite regularly. It's a common practice for them. And Philip's response to that was that they protect, you know, their clients' intellectual property, and that they would not tell me what IC it was. So got nowhere there, which was kind of frustrating because I don't know, if it is just an off-the-shelf Philips chip that's a little more common than what we're looking at here, we could probably get the chips a little bit cheaper. I'm currently having to pay a little over $5 a piece on them. I was originally getting them for $2 a piece, but after I did the video on them, the price went up. Surprise, surprise. But yeah, so price went up on the IC because there was actually somebody that wanted to buy them. Before that, I'm sure nobody was buying them. Nobody even knew what they were. So yeah, I'm getting them from parts recyclers in China that have them. So that's where they come from. But we can just go ahead and assume Philips does not support right to repair, since they wouldn't tell us. No, that's probably not the case. They probably have NDAs. So even if they wanted to, they couldn't tell me because they have an NDA with GM. Not uncommon practice in the engineering world. Okay, let's go ahead and put the springs on next. I just call these springs. I don't know. They probably have a technical name. Seats. I don't know. So yeah, there's a little spring tension to it, holds it in place, and then you solder them on. Okay, so then we have the capacitor. The capacitor is a 0.01 UF 50 volt through hole capacitor. They don't have to be axial like this. The ones I bought were axial, but the other ones will fit. I just wasn't sure if the style that kind of sit up a little bit would fit or not, so I went with axial when I ordered them, because I was not sitting in front of one of these boards. As soon as I did the modification, I was like, oh yeah, those normal ones would fit just fine. Okay, now after that, we're just gonna run little jumpers through all of these guys. So as you can see, putting on these little jumpers is kind of tedious. I'm gonna just stop recording for a second to put these on and get them all on there, and then we will continue recording from there. Okay, so we have all of our components added. So the capacitor is added, the drive IC is added, we put the jumpers on, and now let's just take care of this screen because we already have it off. The resistors on it have the normal, they got so hot they started to crack the solder joints going on there. Didn't really see anything going on with the connector, but we have it apart, so, might as well go ahead and just reflow that because it's no extra work. Okay, and that's it for that. Okay, so next step, we have to program this EEPROM that's on here. So the EEPROM's on the other side of this board. You really have two options. You can desolder this board, take it off. It's all of like 64 pins to get it off of here. Or you can solder some wires to the back of it and program it in circuit. I will be using my Arduino-based programmer that I've done some videos on these. You can check them out. If you just want to make one yourself, you don't actually need the circuit board to make this. You can make it in a breadboard, and you can even leave out the resistors and the transistors that are on here and just go directly to the pins on there. These just turn on and off the 5 volts to the connection here. That gives it a little bit of protection, which is exactly how I fried this. So I was going to use the CH341 alpha to program one of these. I wanted to do a video on programming this with this, but I'm an idiot and I fried mine. I knew from looking at the schematics of this that the pins were always hot on here, that they always had the 5 or 3 volts, whichever one you were giving to it. You always had it on there. But I was testing out a new pogo pin thing, doing a video on it soon. I'm actually, if there's noise in the background in this video, I'm 3D printing one for the recording the next video on this. But yeah, this little pogo pin thing for SOIC 8, was testing it out. I forgot that these are hot all the time, and I was just like carelessly putting it on the board and fried my my CH341 alpha. So yep, fried it. There's absolutely no resistors or anything between. There's nothing protecting the data pins on here. You know, if you give it 5 volts, it's going to send the 5 volts through it. So definitely, if you're using one of these, just be aware that the pins are always hot. Your like mini pros and stuff like that, they are not always hot. They're only hot when it's programming, which just makes sense from a design standpoint. So yeah, let's go ahead and get wired in on here. So on mine, pin 1 starts right here. So all right, let's get the flux out. And if you're wondering how I remember the pins on here, I don't remember them. I actually have a board that I labeled them on and sit it in front of me while I do this. But you can definitely find Google Images this exact thing. I can't remember the keywords to find it. I feel like it had something to do with the Digiprog, you know, that big blue turd for programming odometers. I'm pretty sure it's off of their website that this image comes from on how to do it. But yeah, so 1, 2, 6, 4, 8, and 5. Those are the only ones we need. We don't actually need all 8 pins to program it. All right. And those random numbers I was yelling out, that's the pin order. I should have specified that before just starting to say numbers like a weirdo. All right, so 1, 2, and the next one's 4. And then we go 5. 6 is the green one. And 8. All right, well, let me hook this up to the computer real quick so that way I can program it. Okay, so first we have to select our bed that we need. So I got the 100 mile an hour with trans temp copied. And just because I'm using my Arduino programmer, I have to remove all of these spaces. All right. Okay, and we're gonna go, this is just the serial monitor for that Arduino programmer that I made. All right, so read, let's just verify that we have a good connection. We do. I just remembered that I should definitely save this guy's mileage that's on here. So let me actually do this first. Okay, so now we just need to get the odometer value out of here, copy that, put it here. Now we can copy this, do this, he probably didn't actually need the odometer for this, because this is probably something he's selling to somebody else, because this is going to another technician. But I'd rather give it back to him with the same odometer that he gave it to me with. Okay, so now we can go in. Oops, wrong one. I guess I closed the serial monitor. All right, let's go ahead and write to it so we know we have a good connection. Control V, send. Now, just as a note, a lot of people that have made my Arduino programmer had issues with it, and I think I failed to mention it in the video, but make sure you have no line ending on here. If you have like new line or any of the other ones, it's going to it's going to send a byte before it sends the message, so it shifts everything over one byte, and you're missing your last byte. So yeah, don't just make sure you have no line ending on there if you are using my programmer for doing this. So now we've flashed it with a transtemp flash, so everything should work. We can put the screen back on and give it a test. So it is kind of tedious to solder and desolder these, so I just leave them on until I know I'm completely done with them. So let's get that odometer back on here. All right, that's back on. Now let's just power it up real quick and make sure we got a good write to here. Make sure it boots up properly. Okay, so we powered up. Oh, y'all can't see it. Powered up, doesn't, yep, it's not frozen or anything. So we got a good write to it. So now let's stick a motor where the trans temp goes and actually test it. Now for your trans temp, any of these S-marked air core motors will work, which are the same ones as your Tahoe and Speedo. So if you're grabbing these at the junkyard, or you see a good price at them at the junkyard, go ahead and grab as many as you can, because you can't just buy these motors anymore. You can never remember the correct orientation for it, so I like to test fit one in one of these. This is just the clear plastic. Okay, so that's the correct orientation. That way I don't put it on there wrong. And there we go. Now we can test it. Okay, so now we got it on there. Let's go ahead and just give it a quick test here and see what happens. All right, cool. So it is hooked up. I just randomly stuck it on there, so it's going to point whatever random direction. But yeah, motor's not limp, so it is, in fact, getting power. If you've ever tried to add trans temp without adding these components before, you'll know it just stays limp the whole time. All right, so now I'm going to feed it some serial data and see if we get anything else out of it. Let me find the clip for that. Okay. So yep, there we go. We have a working trans temp. It is responding to serial data. So yeah, it's just pointing the wrong direction because I just shoved a needle on it and didn't actually make sure to set it right. But yeah, that is a working trans temp on here. As you can see, it's a pretty simple process, nothing too crazy. Hardest component to get is that the motor driver IC, and it's really not too crazy to get it, but you know, it can be difficult to find. So let's go ahead and take off these guys and then clean any residual flux off, but I'll clean the flux off camera. I'm not gonna make y'all stick around for another minute or two of cleaning. But yeah, that really concludes doing this. So, you know, the only special tool you need to do this is the ability to program an EEPROM. You don't need the ability to do it in circuit though. You can take this board off and take the EEPROM off and just program it in a little chip reader. So don't get hung up on the fact that I programmed it in circuit. You don't have to do that. You know, just desolder all of these pins. This board comes off and it's the same EEPROM on here as you have on the 9902. Now the data's not the same, but it is the same EEPROM. If you need the files used to program this, you can find them in the Facebook group. Check the description. There'll be a link to the Facebook group. It should already be in there. If it's not, just, you know, add a comment in the group asking for it, and I'll upload it. But I'm pretty sure the 120 mile an hour and the 100 mile an hour are on there. I put the 100 mile an hour on here because that's more common. There's more face options for the guy that sent this to me. But if he wants the 120 mile an hour, it's easy enough to just program that on there. The 120 mile an hour is the Escalade and Denali, and then the 100 mile an hour, that's coming off a 2500 HD gas motor. There's also the 2500 HD diesel that also has trans temp, but that one has a 5,000 RPM 5,000 RPM gauge tack on there. So just something to be aware of there. Of you can't mix up those two because one has a 5,000 RPM, the other has 6,000 RPM. So yeah, that really concludes the video. Thank you guys for watching, and I'll see you in the next one.